So I'm going to talk about beyond big data in the sense that we've heard in the morning, and I think you're hearing everywhere that there's this big data revolution, and it's presupposes the fact that if you have a lot of data, you can do a lot with it. I want to talk about what you could possibly do with it, and what is already being done with it without your presumably being aware of that. So I'll talk about some of the applications that we are seeing in the IT departments and the business sides of major corporations around the world. But I also talk about the web, because the web is where it's actually affecting all of us every day. Right? But before that, a bit of context. Let's see. Today, if you think about it, the past couple of years, most of the newspapers have bad news, right? So the economic crisis, India and Canada were probably less affected than the rest of the world, thankfully, but certainly in the United States and Europe's still continuing. It's pretty bad economically. At the same time, if you think about it, there have been success stories. And there are some organizations, some companies that have done really well. That's a data point which I'll leave with you. The other important thing is that what we're finding is that most of the organizations that have done well have in some way used data in the past few years to do well. So whether it's competing or cutting costs, they've really used data well. So this whole business of there being a lot of data and you can do a lot with it has actually had some financial results. And that's what we've seen with our customers, whether it is using analytics to improve costs inside IT, which we found great examples of, or using analytics to increase reach to the customers. People have done well. Okay, so the next point I want to talk about is what is web scale. So I think this is nothing new about web scale. These numbers everybody's sort of seen, and probably some of them are wrong. They must have grown by the time I wrote them. There's Moore's law, there's Kreider's law in terms of how fast storage is increased, storage capacity is increasing. But the point that I wanted to make is, in a typical large enterprise, the order of magnitude that one is normally used to dealing with is much less. You're dealing with a few thousands of servers, and maybe terabytes of data and millions of transactions a day, as opposed to petabytes and billions on the web. So unlike the 90s, the enterprise IT doesn't lead technology anymore. I think it's been that for the past 10 years. It's the web world is leading enterprise IT, and we're learning from the web companies. And to understand that is also takes a bit of doing for people who are used to being leading. And the fact is that we're not, right? The next point is that the web scale artificial intelligence is actually here. And why do I call it artificial intelligence? Well, think about problems which you never thought could be tackled. And in the 60s, a lot of government-funded research projects were canceled in machine translation because people thought it would never work. But today, it works with some degree of accuracy, and sometimes it goes horribly wrong, but it works. And the reason it works is because there's a lot of data and a lot of a corpus of actual translated text, which makes it actually work. So machine translation is working today. Computer vision is working. You can point things at buildings, and they'll recognize what they are. You can recognize faces in variety of products which we all use today on one's laptops or on the web. And as Perry mentioned, language understanding is moved significantly through the scientific achievement, which was Watson more than a year ago. So when you talk about artificial intelligence, these are interesting applications. I want to take you a little bit down into into the philosophical implications of these things. Since this is not a audience of computer scientists, I'll spend a little bit of time explaining what is this Turing test. Most of you know about it, but some of you may have forgotten. Alan Turing, who was the father of computing in some ways, designed a test or a thought experiment where he postulated that if you have a game where there's a conversation between a man and a woman, and the goal is to figure out who is the man and who is the woman, and the day a computer can answer that or sort of pass that test to a certain level of accuracy that a human being could do, that's when you would conclude that machines are intelligent. Well, he called it the imitation game, and it was sort of derived from a party game which people played. And it was the original Turing test also postulated a different approach, that could you figure out who's a human and who's a machine. And if a human could not figure this out, then the machine was effectively intelligent. Right? Now there's a reverse Turing test. The question is, can a machine figure out through a conversation whether the person they're conversing with is a human or a machine? And I claim that already exists. And that's what you see every day on the web, the captchas that you're forced to fill out, because machines today are not able to figure out those wobbly characters. And so the machine, which is your web server, is actually conducting this test to figure out whether you're a machine or not. Right? But more than that, the machine is now able to do what the original imitation game was designed to do. And it's happening every day. You can figure out what you like, what you dislike, whether you're shopping or just surfing, whether you're rich or you're poor, whether of a particular ethnicity, which is getting into dangerous, spooky areas. And unfortunately or fortunately, it's happening all the time without your even knowing it. So to that extent, the various variations of the Turing test are already being passed. And to that extent, artificial intelligence, by that definition, is here. It's just the trouble with artificial intelligence is once you have it, you change the goalpost and say it's no longer intelligent. So you move on to something else. But as per that definition, we're already there. So add to this technology the fact that you have huge volumes of data on which you can apply these techniques, and suddenly you have the potential for doing things which were once considered impossible. And I'll give you some examples as we go forward. But some of these things we just talked about were considered impossible just a few decades ago. Recognizing faces, translating languages using machines, figuring out from conversations who was actually doing the talking and what their backgrounds are. These are all things which normally one would imagine require human intelligence. So with all this data, there's this pretty well quoted quotation that the point is to understand, not just have all that data. I think it's very important when you're talking about big data, that data by itself does nothing. It's only when you do something to that, and that's where the analytics comes in, that's where the AI comes in. And what I'd like to add to that is the goal of understanding is to predict, and the goal of prediction is to control. And I'd like to highlight that with an example. These are two videos which I'm using with permission from the MIT Department of Neuroscience. It's a popular game which many of you may have played when you were children. It's called Pong, and you can watch this person playing the game, and the red dots are tracking the person's eyes. And contrast that with this person playing the game. And if I may take the liberty of asking a quiz, can anyone spot a difference between the way these two people are playing the game? Yeah, so one is reactive, is just tracking the paddle, and the other one is trying to predict where the paddle is going to go. And do you think it's very difficult to play the right side game? How many think it's really difficult? Well, it's not. I mean, every child plays the right side game. And all of us would play it that way. The left side is somebody with a mental disability. And I would claim that business intelligence today has that disability. So the first speaker talked about business intelligence and the evolution of business intelligence from figuring out what has happened in the past to why it's happened, figuring out what's happening right now, figuring out, other pieces of knowledge, right? And then eventually leading to a state of predictive intelligence. That's the goal. And today we're not there. Today we're on the left-hand side, the left-hand Pong player who's just tracking the ball, just desperately trying to figure out what's actually just going on, rather than what's going to happen. So what we've been trying to do is see whether the AI analogy can go further in business intelligence, and look at a range of technologies that one needs to apply to big data, and look at them from the perspective of an AI landscape. So, for example, if you're trying to play the reactive Pong game, you need to know where to look. Look at the puck. You look at the paddle. You need to know when to go back and forth. You need to look at the stream of data coming in, because you have this puck moving. Sometimes it's bouncing. You have to track it just like you would track an aircraft, to track a submarine. Then you have to learn from experience that it actually bounces in a particular way. When does it speed up? When does it slow down? Then you have to put all these pieces of data together, connect the dots, so to speak, to predict where it's going to be, and then you have to control your actions, to correct your actual action. Now, in some sense, that's what you have to do even to get up here and make a speech, or to pick up a glass and drink. That's part of normal intelligence, or normal motor control. And Perry, who's worked in neuroscience, I just learned, would know that, would have worked on these things. But the thing is that what we're seeing is that organizations need to behave like this. They need to figure out where to look, what data to listen to, how to learn from that data, how to fuse the different data streams that they have access to use that harmonized data to predict things that they want to predict, and then to be able to act on that data. And that's often the toughest one. It's actually shown red here, because you can make all the predictions in the world, but if you're not organizationally geared up to act on it, then it's useless. And often you're not. Often, most organizations today are used to strategic planning at a quarterly level. They'll discuss their sales and their shipments and whatever, and then they'll make some policy decisions. But that's not the way things work anymore. Things are happening on a daily basis. But if the organization is not capable of making a daily decision, then all the prediction in the world and all the speed in the world won't help it. So it's not just about analytics and data, it's also about culture, it's about collaboration and how people work together to take advantage of all the predictions that they have access to. So I'd like to just sort of broadly summarize a few things which I'm going to talk about. The applications of these web-scale AI possibilities and big data. There are three broad categories. The first is the looking, listening, and learning. It starts with social media, because there's been a lot of interest in that in the past few years, but it goes beyond social media now because of other data streams being available now. Transactional data is being sold, anonymized, of course, but it's still being sold. Your movements, when you move around with a cell phone, that data is being used for making predictions. Not about you personally, but about general behavior of populations. It's happening today, and we know that because we work with those organizations. The second piece is, learning, connecting, and predicting. So essentially, using some of these technologies which originate in AI, using them in BI. And the third is control. Once you're able to predict, what kind of applications become possible when you can actually control complex intelligence systems, complex systems, making them a little bit more intelligent. So I'll give you a few examples of each of these. So in the look, listen, learn piece, there are three things that we're finding people are having a lot of interest in these days. One is quite old in the sense of being a few years old, and there's a lot of technology in this area. Who is saying what? I think when you have large volumes of people using Twitter and Facebook, and many of those conversations are public, especially on Twitter, you suddenly know a lot about what people are saying, and you're able to judge the sentiments of people very well. But interestingly, you can do more. You can actually, people don't just talk about their likes and dislikes, they report events on Twitter. And we find that they report events fairly accurately. So you can actually use that to get early warnings of potential disruptions, like our first speaker talked about supply chain. I'll give you an example in a minute where the supply chain disruptions can be actually immediately sensed simply by looking at Twitter. And then figuring out what the competition is up to in terms of, since everybody uses these mediums for advertising, promotions, discounts, just figuring out what the competition is actually doing is one thing that we're finding people are doing. So there's a broad framework in which one does this. So there's all this data from the web, and then you have to listen to that somehow. Then you have to focus, because there's a lot of data coming in. You have to somehow figure out which ones to listen to. Just like if you're in a party and there's a lot of conversations going on, but suddenly you hear something interesting. So your ear is really, your brain is looking out for what's interesting. It's already got that antenna up there. So you have to have that antenna listening to what is interesting. And there's a lot of technologies to do that. I'm not going to get into the computer science of that. I'll just skip that. But what you're going to get out of that are things like, what are the fires in the factories? Where are there strikes? Where are there floods which could affect some supplies? Which competition is giving out promotions, discounts? What customers are making what kind of requests for what? Who's making that requests? Are they influential people? What kind of complaints are people making? Why are they making the complaint? What feature of the products are being discussed and complained about? And who are these people? And interestingly, so this is not about sentiment. So the first wave of this listening to the customer is all about sentiment. Sentiment analysis, I think people have beaten it to death in the past few years. It tells you most of the time what you already know, right? That some brand is doing better than the others. It tells you about a little bit of sudden dips and fluctuations in the brand sentiment. But these kind of things which tell you specific events, specific activities of competition, specific problems that customers are facing, they turn out to be much more valuable if you're able to harness them. So, so out of this data, you're able to figure out, generate events, figure out the relationships between the people who are making these these comments, figuring out who they are. And I'm going to skip the rest of this slide because it's getting a little technical, but I'll just give you an example of that. So I was making this chart about a week ago, and I just went to our viewer, which this may not be able to read everything here, but even I can't read it. So there's some factories which caught fire on the 13th of April, and I get this every morning. Unfortunately, I couldn't access it this morning because it's only accessible from our network, not on the web. But every day we get this. So I know there are about a dozen major factory fires in the world today. I know that because we're getting all the tweets, and they're all been going through our process, and we're listening. And this feed is available to our customers, and if our customers know where their suppliers are, their contract manufacturers around the world, which is in the global supply chain, and if there's any disruption to any factory nearby or a fire, they can immediately call up their suppliers. Are you affected? It's a rare event, but knowing that is a huge advantage to know that today rather than 2 weeks down the road when the suppliers stop coming. Right. So that's one example that I'll give an example of. The other example was competitive intelligence. You can actually figure out things like what organizations supply what products to other organizations simply by mining the news. And that's data which is not easy to get access to, because nobody actually tells, like your supplier is not going to tell you where they get their supplies from. It's very difficult to get that data. It's actually confidential data. But the trouble is the web makes everything open, and so a lot of things are no longer that confidential. Because when they sign up for customers, they sort of have a nice announcement in the press. So systems start mining that, and suddenly you have this network being built up of an approximate picture of your supply chain. And that's also very valuable in the global supply economy. The next piece is the connect piece, which is fusion. That means how does all this data come together? So you all these things happening on the web, promotions. But the question is, did such an event impact us earlier? So you need to know whether such events actually impact you. So you have to fuse that with your data, where your suppliers are. Did similar promotions by competition affect one's sales? Which particular locations did they affect more? Which customers are actually making complaints? Are they actually your customers? You have to sort of link these identities. So the real value comes not just from listening to data from the outside world, but also in terms of putting it together with data which you already have internally, right? So a couple of examples of how this works, and some of which are a bit scary. One is getting behavior patterns from social media and using that to get a much more focused signal about where the demand is changing. A little bit more futuristic stuff, behavior patterns using vision and robotics. I think our first speaker mentioned about looking at videos of people walking around in a shop. I'll give you an example of that in particular. And then, going beyond dashboards, and I'll explain that when I come to it. So we did this little experiment. This is 60-odd hours of Twitter data, which actually was tweeted by people who had GPS-enabled phones. About 1.5% of people who use Twitter have GPS-enabled phones, and they transmit their GPS locations when they tweet. And you'll just see, if after this few charts, you'll probably stop that if you have that on your phone. Okay. So we broke the world up into rectangles so we could grab enough tweets. So in each rectangle, you can get all the tweets which have a GPS data attached to them. And then you could see all of them. You can see that, interestingly, Mexico and South America were higher than the US, which is very surprising data for us. Maybe it was in that time period. We haven't done more analysis after that. But, So, okay, we took a random tweeter. I won't give, we have a lot more information about this person, because everything's open on Twitter, but obviously for privacy reasons, I won't put that up on the screen. But that person belongs to New Jersey. He tweets mainly from two locations, which presumably are his home and his work. Or I'm not even saying it's a his, it could be her, I'm not revealing anything. It looks like this is his home, or her home, because it looks like a residential area. It looks like this is where the person works. Where's the privacy? It doesn't exist anymore. So the point is that not that you could track a singular person. The point is that if you had millions of such data points, and the amount of such data is just growing. Whether it's and I just use Twitter because it's public and open. There's no problem talking about it here. But there's other data which I would not be able to share, the kind of data that some organizations which you all use have that data, and they're able to use this. And aggregated, you're able to figure out what people do, where they go, when they go, to which places, which shops are frequented more often, which bank branches are frequented more often, and you tie this up with with data from different sources, and suddenly you have a living lab of behavioral patterns of people. And suddenly you use that behavioral pattern to figure out, you fuse it with actual sales, shipments, and other data that you have from your own organizations if you're selling things or making things, and suddenly you're able to get a much finer picture of demand and how demand correlates with behavior. And if you're able to find some statistical correlations in behavior patterns, then you can use those in the future to better predict demand. And once you can better predict demand, if any of you are familiar with supply chain, you're suddenly able to reduce inventory costs, suddenly able to plan much better, because all the cost in supply chain is on inventory. If you can reduce that, it suddenly becomes huge. Now this is all science right now, it's research. All our customers who are early adopters of technology are exploring exactly these kind of things today. Nobody's done it, but it's going to happen within the next year or two. Nobody's actually done it, but the data is just coming together today from a variety of different sources. Some more researchy stuff, visual learning. So just to give you an example, I mean, 15 million hours of video are uploaded in a year in YouTube. It's video about everything, birthday parties, whatever, right? In a human waking lifetime, approximately 16 hours, 90 years, we view about 500,000 hours of video. That's what you see. So there's a much more available to the computer to actually do something within just 1 year. So, think about it, like Amazon. People like you buy the kind of books you like, and the books you buy are bought by people like you. So there's that two-way bipartite relationship where that's how Amazon does recommenders. It's the same thing in how you learn concepts when you see. Nobody tells you that this is a chair. You just sort of figure it out, right? When you're a kid, when you're a baby. So the features, similar objects and similar activities co-occur with similar features of objects, and that's how you actually learn. So there's a lot of computer vision work which now, in the past many years, has been able to learn things from grounded bottom up rather than a top down supervision. So we've done some of this stuff to figure out what kind of things, what kind of activities people do. And we're sort of building something like a video parser. So you can take a video and just parse it, and you get a sequence of activities coming out. Now, maybe I'm getting into too much computer science, but let me just go to an example. Two technologies are making this extremely interesting. One is what your kids may be using at home, which is the Xbox Kinect, which now suddenly is a depth camera. And the other is when these very low-cost robots. This is called a TurtleBot from Willow Garage. There are many others like it. It's got a Kinect attached to it. And with such devices, what you can do, this is a little experiment, which I'll show. Somebody walks up to a potential, this is data from a Kinect, and he's putting their hands, presumably looking at things on a shelf, and it's counting who's looking where, what, and how many times. And suddenly you can imagine this in a store, and suddenly the data about how many times a particular part of the shelf is accessed, which is that kind of data, suddenly becomes available to you. It was never available before, because you couldn't do this. And you can do this if there's, now imagine this little robot walking around the store now and then and taking sample data from different parts, and suddenly you have a data stream which never existed. So now these things become possible, and suddenly opens up a lot more data. The next very important application is, this is a typical BI screen, okay? There's a dashboard. There's I think we saw many such dashboards in the first, thank you. So we saw some of these dashboards in the first keynote. The trouble is, so far we rely on the human to actually figure out which part of the data to look at. You have to scroll through various graphs and various bar charts and pie charts to figure out, oh, that looks interesting. The challenge for BI is to tell me what is interesting and why. You should look at this. Why? This is an example. Something happened. A promotion by a competitor happened, and you should look at this because last time something like this happened, sales in this part of your universe dropped, so better go and do something about it. So the kind of technology required to make this stuff happen is just getting there. So obviously there's the obvious technology stuff which you may have heard of already, the big data warehouse technology, which is, there's distributed processing and all that fancy stuff, which is all it's saying is that there's a whole bunch of people who figured out how to do database technology at 100x scale because they worked in Google and Facebook and they had to do it there, and the old databases didn't work. And now everybody who doesn't have such a big database is being asked to use this technology regardless. That's one message that I'm getting. That don't look at the technology just for its own sake, okay? Because you may not need it. What you may need is a lot of the lessons around that technology, which is how do you put data streams together in real time when you don't know how to correlate them? How do you correlate them approximately using machine learning and things like that? But more interesting in the pun in this sense, how do you figure out which parts of the data have interesting correlations? Interesting in a very technical statistical sense. That correlation is statistically significant, and how do you do that? That's actually an arcane topic, which even most statisticians don't look at too much these days, right? What is interesting? So this definition of interesting has to be carefully understood, right? And even more challenging is how do you figure out what features the data should have? What features should we extract from the data itself, which give rise to interesting rules? Right, so that's a totally open topic today. So today it's all data scientists have to do that. The work of the data scientist itself, if it can be automated and then scaled up tremendously, then you suddenly have a lot of possibilities. Okay, I'll end with just a few more examples. The predict correct intelligent systems. So how do you use all these predictions and build intelligent systems? So we've seen some examples in the morning as well. Pricing, planning, retail, supply chain, logistics, planning. Planning generally has been something, but we've been doing that for many years now. But more interesting is that when you build intelligent systems, we are finding that you really can't do this planning precisely. You can only provide support to humans. That what you really need to do is put humans in the loop of decision making in a way that they've never been there together so far. So it's really using collaboration technology, which you use every day, Facebooks and the Twitters, but use it in a purpose-specific way. It may not be the same tools, but so that you can make decisions better when you're given a lot of data. And then lastly, control. So when you have response, you're able to respond faster in real time. Marketing is the obvious situation where you can respond to consumer requests, but security, energy, etc., all control things, right? So I'll skip some of this. So energy distribution is an area which we're looking at very closely in terms of how do you do better metering, how do you do home energy management, how do you look at different types of generation and things like that. But before, this energy space is, a lot of people talking about the energy space. It's going to take a long time before this gets there. There are a lot of interests which don't want this to happen that quickly for obvious reasons. So even before you'll see any of this energy stuff, you're going to see something else. Anyone seen what this thing is? Yeah, so this was the DARPA Grand Challenge car called Stanley, which came out of Stanford, and this is the Google self-driving car. Now, right now it's just a self-driving car, but now just think about it as a control system where you have many cars, and you have all their data, you have maps, you also have search, social networks, people tweeting, talking, conversing, and suddenly you have behavioral patterns, and suddenly you're able to do all kinds of things. And now that becomes a complete worldwide control system. Also a bit spooky, but it's possible today. Okay. So I'll end with I'll just skip this. That there's something to do with the cloud in here, but I'm gonna skip that. Okay. So today there are three things. If you think about what is happening in the world, there are basically four things that our customers are looking at today, most people. One is social media, mobility on the other hand, cloud and big data are the other two. And we have looked at, we have points of view in each of these areas, and I won't talk about all of them, but what we talk about in big data is this whole concept of information fusion. How do you get data from different pieces of the enterprise as well as from outside together, and how do you correlate that, detect interesting patterns automatically, and that's what we're looking at. So I'll summarize by just saying that what we really want to do is get back into using AI for BI, which we sort of lost over the past 20 years. There was a lot of data mining work in the late 80s, and then BI became just reporting, right? And it's time to go back to data mining. So the messages are fusion of external data and internal data, using AI techniques for listening, focusing, and fusing, and leveraging big data platforms and the cloud. So I'll end with that. Right? Thank you.